So today's lecture is about 4.7, but I decided to split it in two different videos because it's kind of slightly two different things and I don't want to confuse matters too much. So the first thing I want to discuss is actually what's called the general solution of a linear system of equations, which is somewhere, if you look in the textbook, somewhere halfway discussed. But I'm singling it out here in this part here. So what are we talking about? So we have a linear system of equations, so I'm going to write down one and we'll work out the details of it. Now, how does it normally look like? We have a matrix, and then these are the solutions that we look, and then we have a constants, right? So these guys have the right sizes, of course, for this to make sense. And so this is the coefficient matrix of the system of equations. This is the coefficient matrix. This is the variables that we are solving, and these are the so-called constants. And we have seen that sometimes a special case of these constants is if we have the zeros here. So we call that a homogeneous. It's a term that we have to get used to because it kind of plays a role here. So this is a homogeneous, and this would be then inhomogeneous or non-homogeneous equation. Now the reason that I mention both is because there is a connection between the two. Okay, and so I want to work this out on an example to show you what the connection is, and then I'll formulate it more generally. So the system of equation I want to look. I'm going to write a matrix already. So our matrix that I have in mind is 1, 3, minus 2, 0, 2, 0. It's a kind of 6, as you see, variables. 0, 0, 5, 10, 0, 15, and 2, 6, 0, 8, 4, 8. And so we see this is a matrix of 4 by 6 matrix, so 4 by 6 matrix. So this means we're going to have 6 variables, right? So this will be x1, x2, x3, x4, x5, x6, and that is unequal, and so our constants, the b here, so this is our a, the b will be 0, -1, 5, 6. Why only 4? Well, think about it, right? So this is a 6 times 1, a column, and if we multiply this, the result will be a 4 by 1, in other words, a column of size 4 here. Okay. So the measurements make sense. Okay, let me erase now everything underneath here. Okay, so this is the system we want to solve. And we know how to do this. So this is somehow, some sense not new. I just want to point out something because this is something, it leads up to the next part. So I hope you're watching this first. Otherwise, yeah. It will make the part 2 more understandable, I hope. Okay, so we know what to do. We have to row reduce this matrix, and so we're looking for pivots. In our first column, we have already a pivot, the 1 there, and so we have to make these 2 guys 0. Okay, we know how to do that. So we have row 2, replace that row 2 minus 2 times row 1, and row 4, replace row 4 minus 2 times row 1. Yes, yeah, okay. So we get, and remember what we actually do is, I'll do it while I'm writing this one down. We also have this column here in the back, right? So we actually, yeah, so, okay, it's a little bit of writing, but I'll do it. So in the back now we write this column here, right? That's the augmented matrix that we get by adding this column. And now these are the row operations that are going to apply here. So the result of the row operations comes here. I should write it there. Okay. So I get 1, 3, -2, 2, 0, 2, and in an augmented column I have 0. So I multiply here with -2 and add up to this one, so that's 0. -2, oh, that's also a 0, -4, that's -1, -2, 0 again, and -3. And don't forget also the last column, that gives this. We don't do anything with the next guy. And then finally, the last one we do the same thing, -2 and add up. 0, 0, 4, 8, 0, 8, 6. Okay. So this is our first pivot. We look for now, this means, remember what this means, right? So perhaps a bit a while. From now on, we are now concentrating on what's left, the matrix below here, and we look at the first non-zero row, which is this row. So we're looking for a pivot in this row, and this is the pivot that we have in mind, but I should change the signs here to get the real one. So I'm going to do that quickly. Row 2, replace that with minus row 2. Okay, I'm going to write. Okay, it's a video, so we can be a little bit more creative with videos, right? So I'm going to erase my negatives. Okay, so this is now the result of this row operation. Okay, so in other words, we have done this now, that's why I scratch it out. And so we have now our 1 here, and what we now want to do is of course make these two guys 0. Remember, we're only looking everything below this green line here, so nothing yet above. Okay, so the row operations that will do this for me are row 3, replace that by row 3 minus 5 times row 1, and row 4 minus 4 times row 2 here, row 2, sorry, I'm working with row 2. Okay. Okay, can bring this up a little bit. So what we have, nothing, as we said, this is now a row that we don't touch anymore for a while. 0, 0, 1, 2, 0, 3, 1, neither this one. Now we do this one here. So this is the -5 and then adding up there. So it's a 0. It's also 0, a 0, a 0, and a 0. Oh, that's nice. I like a lot of zeros. Okay. So now with -4. Okay, so -4 and add up there. We get a 0, a 0. Oh, also 0. Oh, also 0. Oh, also 0. Ah, okay. Here we get something. We get -9, so -1, and then no, sorry, we're -4. Sorry, it's negative. -12 plus 8 is -4, right? Okay, and then 2. Okay, so what does this now mean? Well, remember, going back to, we have now fixed these two pivots. What's left is this guy. So we look at the first non-zero row, which is the very last zero column, sorry, and that's the very last one. Okay, so I have to make this a 1, which is a little bit annoying. I have to divide here by 2. I'm a little bit concerned that did I make a mistake here? Because it's -12. Sorry, I'm looking at my calculations here and they're off by 1. Okay, what did I do here? Okay, sorry, I want to make sure that I don't give you mistakes. Oh, I see, I just copied it something wrong. Okay, fine, okay, this is fine. It's slightly different from the one in the book, but that's fine, and here's another example. Okay, so, good. So, again, I need to make this a 1 here, so divide. So I'm going to do row 4 divided by 4, -1, 4. Okay, so again, I'm cheating. Well, not cheating. I'm using the technology, right? Now that we have this, let's do this. So you can always go back if you forget what it was. This is 1, and this would be -0.5. Okay, and so this is our last pivot. Now, actually, I did do something a little bit wrong, right? Because the pivot should have been in this row. So actually, I also have to interchange this row. So I also have to do swap row 3 and row 4. I should perhaps even have done that first, which means that the zeros now come below. Again, I'm gonna make my life a little bit easier by saying that, okay, this 0 now, they actually go below. So I get 0, 0, 0, 0, 0, 0, 0. So that now I truly have echelon form. Okay, and so let's review a little bit the terminology here. The variables that correspond to the pivots are called the pivot variables. So these are my pivot variables. So this is corresponding to x1, x3, and x6, right? The first, third, and sixth one. Meaning that the others are the free variables. So the free variables, so x2, x4, and x5 are now the free variables. Okay. However, of course, this is not the end of the story, because this is only echelon form. We have to go to reduced echelon form. So this is now working phase 2. So phase 2, we go to the reduced echelon form. And this means that I have to now build zeros on top of this guy, on top of this guy, and that's the only two things I have to do in this particular case. Okay. So, what are the operations? I have to now work from bottom upwards. So, the first thing I'm going to work is with this guy. And so, the row operation I'm going to do, let me write it here. So, remember, these already carried out, right, in this new picture here. So, what I now have to do is replace row 2. This is now row 2, right? And replace that by row 2 minus 3 times row 3. What we get, so I get a little bit, and they have a 0 already here, so there's nothing I have to do there, okay? So I get 1, 3, negative 2, 0, 2, 0, it's 0, now we have the 0, 0, 1, 2, 0, so I'm going to multiply everything with negative 3, so this becomes 0, and then what happens here, I have to remember, negative 3 here, right? So negative 3 times that is 3 halves, and then added to 1 is 5 halves. Okay? And, yep, that's that. And then the rest is copying, 0, 0, 0, 0, 0, 1, minus a half. And of course, that's just a 0 row. I don't care about that really anymore, but I still keep writing it. But for a reason, because you'll see in the part 2 that it we want to keep track of this somehow. Okay, so that takes care of this pivot. So the next pivot is this one, and that's the row operation. I mean, this is the guy that I want to get rid of. So row 1, replace that by row 1 plus 2 times row 2, and the result is 1, 3. So now I multiply this negative 2 and add up with plus 2 and add up. So then I get a 4 here. I have already a 2, that is just a 0. And then I multiply this with 2 and add up, so this becomes a 5. And that's the only thing that I do, so everything else is copying. And now I truly have an echelon form, and these are my pivots. And so you remember the pivots, these pivots should now really be only ones and one and the rest is zeros, okay? And as before, we have now the free variable. So what was the meaning of all this now? How do we interpret this? This means, remember, these are the coefficients of the axis, right? So we have, if you want to write down, I'm just writing down here, what does this mean? This means 1 times x1 plus 3 times x2 plus 0 times x3 plus 4 times x4. Perhaps if there are so many of them, let's list them. x1, x2, x3, x4, x5, x6. So where 4 plus 2 times x5 plus 0 times x6, so I shouldn't write that anymore, equals 5. That's the meaning of this first row. Okay? And so what we do then is we say, okay, we write x1, my first pivot variable. So the pivot variables always will be in terms of the free variables. So the pivot variables in terms of the free. And let's make them blue here, right? So these were the blue variables here that we had in terms of the free variables. Okay, so it is x1. Well, so this means, of course, that we have to bring this to the other side, which means here that we're going to have negative signs. So we get x1 equals minus 3 times x2. Okay, so the only variables that are matters, the only three variables are these. Let me make the columns a little bit more explicit. So minus 4 times x4, minus 2 times x5. And not forgetting plus 5. Okay, that's the first of the black variables. What about the next pivot variable? So x3. x3 is now, notice that x3 will involve only these two guys. In fact, in this particular case, it doesn't even involve one of them. So minus 2 times x4, bringing this two to the other side, right? The 0 doesn't matter, plus 5 halves. Okay? And then finally, the last one, x6. So x6, this is the last of my pivot variables. I have nothing anymore except the constant that is equal to minus a half. Perhaps I should do it in blue then. Minus a half. And then the way to write this is let's write this now in terms of okay, so let's write now the whole thing, x1, x2, x3, x4, x5, x6, write it in column form. So we get minus 3 times x2, minus 4 times x4, minus 2 times x5, plus 5. X2 is just x2, right? There's nothing to it. x3, there's again a formula for that. That is minus 2 times x4 plus 5 halves. What about x4? Well, that's just x4. x5 is just x5. These are the blue variables, right? Oh, sorry, I'm not doing my color scheme all the time here. And then finally x6. x6, again, I have a formula that is minus a half. Now, why do I do this? Because I want to now write this as in terms of the three variables. So in other words, what I'm looking for is what are the so again, in here, in this column, what are the coefficients of x2? Well, we have a negative 3 here. We have a 1. Okay, I don't show that one, so let me perhaps not do this. There's nothing in the next row, and in neither of the next rows have anything to do with x2 anymore. So this is x2 times this vector. So the x2 really is actually, it's a coefficient, right? So what's now the coefficient of the, what can I, if I factor out x4, what do we have? Let me underline a little bit. Here's x4, and here x4. So if that worked, plus x4 times, what I have, a negative 4 there, nothing on the second row, a negative 2 the third one, a 1 in the fourth, a 0, and a 0. Okay, and then do the x5 is the last one, right? So here's an x5, and there's an x5, and this is the only x5s that I have, right? Okay, so plus x5 times Ela, where did it go? Minus 2, 0, 0, 0, 1, 0. Make sure that you put it in the right order, everything. Now, but there is something more, right? Because I have the only thing I have now not yet written down is these constants here. So let them write down, but since I'm running out of space, and also because we normally do this, I'm going to write them in front. So what I have is 5. Well, what's the constant in this one? Well, it's not there, so it's 0, right? So 5 halves. The next one, again, 0 and 0, and minus a half. Sorry. Plus. All this is plus, right? So if, in other words, what I'm saying is I untangled this column and becomes this. And this is a practice that we're going to need to do more. And so that's why I want to do this separately in this video here. Now, what's the meaning? Okay, so this is the meaning of the general solution. This says that no matter what, so x2, x4, and x5 are free variables. And what free means here is that you can choose whatever values you put in there and you get a solution. So if you take x2 7, x4 5, and x5 minus 3, you calculate the whole thing, you get a solution. And no matter what you choose for x2, x4, x5, you get a solution. Now, we were talking about the general solution. That's what I mean. So why did I bring in this homogeneous equation, which would mean that instead of this column, we would have just zeros? Okay. Well, the nice thing is that this is the constants, right? Now, this part, which contains these free variables, so the part that doesn't, this is the part without a variable in front of it. But the rest is actually the solution, the general solution of the homogeneous equation, of the homogeneous system. And why is that? Well, think a little bit about it. Where did these numbers came from, these green ones, this light green one? Look at where they come from. They're coming always from the back, from this back column, this augmented column here, right? Trace it back and you see that's exactly where they're, well, here they're listed here, right? So now what's the difference with the homogeneous system is that this back column here would be just the zeros, and therefore we would just have zeros there. So if you would solve this system of equations with the different constants, in particular with just zeros, you do exactly the same things, except that now your last column is all zeros, right? And at the end, what you find is, well, everything except for this. So that's the homogeneous solution, okay? So what's the conclusion of this? And this is something that can be very useful sometimes. What this conclusion means is that if you take the general solution, is what this one here we call P, a particular solution. So x vector, there are vectors, right? xp, and so this we will call xh, the homogeneous, the h of homogeneous, and this is the p of particular. And so this says that we can write this general solution in two parts. One is a particular solution, which consists just of a vector, and the others is actually not just a vector, it's actually any vector in this of this form. In other words, this lies in the span of these three vectors here. So the three vectors have -3, 1, 0, 0, 0, 0. These column vectors, right? I'm writing them as columns. -4, 0, -2, 1, 0, 0. And finally, -2, 0, 0, 0, 1, 0. Okay. And so what we see is, first of all, we know, if you remember this, go look at the back or look at the notes. The span of vectors, that's a subspace, right? And we also said that the general solution of a homogeneous system of equation forms a vector space, and we already mentioned that how they can find, given a homogeneous system of equations, how we can find the vectors that span it. Okay, so that's basically repeating what we did last time. And so what we're saying is we get this subspace. So this is a subspace. Which consists of the general solution of that homogeneous system of equations. And in that subspace, we have all these vectors sitting. And that what this now says is that if you want a general solution of your original equation with the constants, so the non-homogeneous equation, then you get, how can you write it? Well, you find a particular solution, this one, and then any other solution is just obtained by adding one of the vectors of this subspace. Now, notice that this particular solution, it's not something that I just could read off, right? It's not that this is anything to do with the original constants. Do not confuse this. I still have to do the whole calculation to find them. But once I have them, I have everything. Okay, and so there is a homework problem that asks you to find the general solution of a system of equations, which you do, and then says, and now what is the general solution of the system of equations of the homogeneous system? Well, that is, you just ignore the part that has no variable in front of it, and you look at this, and that's then what you get. But there's one more thing to say. I said this is the span, right? I got these three vectors in the span, but we are much in better situation now. This is not just spanned by these vectors are now a basis. So in fact, what we have shown is, so I'm going to write this here, instead of span, that these three vectors here, let's put it in a bit different color that you see what I mean. A basis of this subspace, a basis consisting of this general solution of a homogeneous system is exactly this. And where they come from, it's exactly these three columns that we have then formed after you do all this manipulation. Okay? So this method gives us not just the general solution, it also gives you a basis for the general solution of the homogeneous system. Now, you say, why is it not of the general solution? Well, the solutions, the set of solutions of a non-homogeneous equation, unfortunately, is not a vector space. Right? We had discussed this. A line to the origin, that's a vector space. A line that's not to the origin corresponds to the linear equation that has a non-homogeneous coefficient, is not a vector space. Okay. So now, how this is going to link to the next video? I'll already tell you this. We will call this subspace, that's the general system of solution of this homogeneous system of solutions, also the null space of the matrix A. Right? Null, zero, so it means just basically, okay, you look at the system of equations and you look at given this matrix here, the null space of this matrix is basically just the general solution of a homogeneous system of equations given by this matrix. And so what I've just explained now tells you that we have a method of finding a basis. And that's what I will explore this more in the next video.